Hi guys. Alrighty, here is our lecture on your favorite chapter, which is Neuroscience and Behavior or Biopsych. There are all the brain parts in here and the neurotransmitters. Alrighty. So, history of the mind. Who was the person in charge of the whole, different bumps on our heads represent different functions? Who was that person? And what was this whole idea called? Okay. It was called phrenology, and the person in charge of it was Franz Gall. Okay, so then we have the parts of the neuron. Do you guys remember how to draw the neuron, what the different parts represent? So this is the cell center, which is the cell body. What is another name for cell body? It is soma. The crazy Einstein hairs is going to be your dendrites. This is going to be your axon, which is the long skinny part. Then you have the little fatty sausages or marshmallows, which is myelin sheath. You're going to remember that because M is for marshmallows and for myelin. And then this whole process is called a neural impulse or an action potential. And then these little feet things are called terminal branches, synaptic terminals, and then the gap between one terminal buttons to the next dendrite is going to be called the synaptic gap. Okay, so the life support center of the neuron is the cell body, also known as the soma. The branching extensions at the cell body, which receives information from the next neuron, is going to be dendrites. Then the long part is, again, the axon. It is covered by myelin or marshmallows. And then the branches that shoot out to neurotransmitters is going to be the terminal branches or terminal buttons. Okay, again, review dendrites. It's going to gather information from other neurons. It takes information to the cell body. Cell body is also, excuse me, is also going to be called the soma. It also contains the nucleus. So the nucleus is going to contain the chromosomes, which has the genetic materials. Okay, the axon, again, is the long part. It is going to take things away from the cell body to the terminal buttons. Again, it is covered by myelin sheath or the little fatty marshmallows. And so this basically speeds up the action potential, and it's going to increase the velocity of action potentials. Okay, then we have that node of Ranvier, which basically means the gaps in between each of the little fatty sausages. Okay, at the end, it's going to be the synaptic terminal or terminal buttons, and it's going to basically shoot out neurotransmitters into the next dendrite. Okay, so the whole process, the pathway is the SATs, or dendrites, soma/cell body, axon, terminal buttons. And so remember we did the activity where we stood around the classroom and then we pretty much had to be side by side by a friend, and then we interlocked our hands. So that whole idea was pretty much us representing the transmission of action potentials. Okay, so an action potential is going to be a neural impulse. As it is going down through the axon, you're going to have positively charged atoms inside and outside as they are going kind of like rotating through the action potential. Okay, so then we have, remember this whole process, we have depolarization and hyperpolarization. So depolarization occurs when positive ions are going to enter the neuron, making it more likely to fire an action potential. Whereas hyperpolarization is going to be when negative ions enter the neuron, making it less likely to fire an action potential. So we had drew this on the board, and this is actually wrong. This should be polarization. So pretty much this whole analogy, we connected this to flushing a toilet. So when you enter a toilet, you don't enter the toilet. When you enter a bathroom and you see the toilet, okay, the water is just still, nothing is happening. This is called polarized. So when it's doing nothing and it's just hanging out, positive ions are on the outside, negatives are on the inside. Okay, then you have to flush using the handle. So once it flushes, the water goes into the tank And so in this case, in a neuron, the positives go into the toilet, or it goes into the neuron, and the negatives go out. And that's called depolarization, which makes it more likely to fire. Then we know it can't always constantly be firing. So at some point, the positives have to go back out and the negatives have to go back in. So then it's hyperpolarized. So that way it's less likely to fire. So once the water has settled back into the tank, we have to go through this resting pause or this refractory period. So when else have we heard of refractory period? It is going to be during the sex stage. So it's pretty much just resting pause where the neuron has to recharge itself. So then it can go all the way back to being polarized again, and then it's going to fire and depolarize, hyperpolarize, then go back to polarize, depolarize, hyperpolarize. So hopefully that makes sense. And the whole sodium-potassium idea, the sodium-potassium pump, we had used a potato chip. So remember, on the outside, the potato chip is salt, which is essentially sodium, and then the inside is made out of potatoes, which is potassium. So that's kind of how we represented that whole process. Okay, then we have something called a threshold. So the threshold essentially in the toilet example is going to be the handle. So once you push the handle to a certain point, like past the threshold, then it's going to fire. Same thing when it comes to neurons firing as well. Okay, then of course, again, a neuron has to take a pause, which is the refractory period, which is where they're going to recharge, and then it can fire itself again. And then sodium potassium pumps, again, we use the potato chip to represent this whole process as well. Okay, then we have the all or none response. Basically, it's either going to fire or it's not going to fire. It's either going to flush toilet or the toilet isn't going to flush. Alrighty, then we had, remember when we were standing side by side and we had to then interlock our hands in order for us to then fire and transmit information to the next person's neuron. This thing in the middle was called the synaptic gap or the synaptic cleft. So you basically, one neuron's terminals is going to shoot out the neurotransmitters. It's going to go through this gap, and then the next one is going to grab onto it, and then the neurons are going to interlock. Okay, so again, the toilet flushing, we did this. All right, then we have neurotransmitters, which are super important. So you have to know your neurotransmitter chart. So this one is basically saying that neurotransmitters in the synapse are reabsorbed into the sending neuron through a process of reuptake. So the reason certain medications work, such as antidepressants, is because it's going to leave extra serotonin in the system, so that way they can feel better and lift up moods instead of having it be reuptake. Instead of it being sucked back up and having the process of reuptake, an antidepressant is going to block that process, so that way we can have more serotonin in our system. Okay, so here are all your neurotransmitters. We have to know what disorders go with it if there's too much or too little. Okay, the first one is going to be acetylcholine. Acetylcholine is going to be tied to Alzheimer's disease because it is A in A. So in this one, how about this? I'm just going to remove all of these. Okay, so we're just going to remove all of these so that I can write on the board. Okay, so acetylcholine is going to be dealing with Alzheimer's disease. So if there is too little acetylcholine, it's going to lead to Alzheimer's. Okay, when it comes to dopamine, two disorders. Dopamine is going to lead to schizophrenia if it has too much of it. And because this deals with learning, attention, and emotion, it's going to lead to Parkinson's if we have too little dopamine. Okay, serotonin is going to affect our mood, hunger, sleep. If you have too little serotonin, which is mood, is going to lead to then depression. And so we want Prozac to be able to lift up serotonin so then our moods can be lifted as well. We also talked about how turkey, after we eat a large, Thanksgiving dinner, we start feeling sleepy because serotonin is released by turkey when we're eating turkey, so it deals with sleep as well. Okay, norepinephrine, these are all your A words. Okay, it's going to be alertness, arousal, attention, adrenaline. Okay, too little of it is going to lead to depression. And then in our other chapter, we talked about if too much norepinephrine is in your system, it can lead to a manic episode for bipolar. Okay, GABA is an inhibitory transmitter. If you have too little of it, it can lead to seizures, tremors, and insomnia. Okay, glutamate, this is an excitatory neurotransmitter. And so we talked about if you have too much of glutamate, which is found in MSG, you can get migraines and seizures. Okay, so just make sure you guys know all of the neurotransmitters. All right, again, kind of like the lock and key mechanisms when the neurotransmitters are pretty much transferring information. Okay, what is it called when it mimics the neurotransmitter? Okay, this one's going to be called an agonist. And so morphine works in our system, and morphine is going to basically mimic endorphins. It's why when we take morphines for pain, it makes us feel good, our mood is lifted, we feel happy, sometimes we feel high. And so because morphine essentially is an agonist for endorphins. And then quick review, we didn't talk about this. Endorphins is going to be your happy neurotransmitter. So serotonin is more mood. I would rather have you guys use that word, whereas endorphins, you can say it's a lift of mood or it's happy feelings. So it's also called the runner's high. Okay, so something that's going to block the neurotransmitter, this is going to be called an antagonist. So kind of like an antagonist in language arts, it's going to basically be blocking your goal. And so when it comes to using these, what's it called? Oh, Botox for people's faces, or this like tranquilizer. It's going to basically be a blocking of acetylcholine. So acetylcholine helps with muscle movement. And so if I'm blocking muscles, then Botox is going to prevent wrinkles on my face. So Botox basically serves as an antagonist to acetylcholine. It's going to block that function. Okay, and then we have our lovely nervous system. Can you draw the whole nervous system out with all the different parts and the little components underneath it in the flow chart? So we have everything in the middle is going to be called the central nervous system, which is brain and spinal cord. And then everything else is going to be the peripheral nervous system. Okay, so the nervous system is very speedy. It happens very quickly. Again, the central nervous system has the brain and the spinal cord. And then the peripheral nervous system is going to be the sensory motor neurons that connect to the sensory nervous system and to the rest of the body. Okay, so this is the helpful flow chart. So you have peripheral and you have brain and spinal cord. This is obviously the easiest one because it just has brain and spinal cord. It's in the center of your body. And then the peripheral, you have these self-regulated actions of internal organs, which is the autonomic, which looks like automatic. And then this one is going to be somatic, which is going to be your voluntary skeletal muscles. So it's the S and the S. So this is like raising your hand, kicking a ball, dancing, taking notes. Autonomic is going to be all your internal functions like breathing, heart rate, things that we cannot control, digestion. Okay, and then to make it even more complicated, underneath the autonomic, we have the arousing part, which is going to be sympathetic. So sympathetic is not only arousing, but it's also your fight and flight and freeze component. So we can't help it when we get afraid or feel fearful. If we're watching a scary movie and there's music in the background, our natural system automatically becomes in a state of fight or flight. It's also people that have a lot of anxiety are also in a constant state of fight or flight. I would say during this whole COVID-19 thing, there's a lot of people's nervous systems that are super on sympathetic arousal right now. And because there's a lot of fear, there's a lot of panic. And so that's not always good for our system. So we then need the opposite section, which is going to be your parasympathetic, which is going to be the calming. And remember, we talked about parasympathetic calming is kind of like a parachute where you're going to go, wee. Sorry, it's really hard to draw with this pen. And you're just going to float calmly downwards. So sympathetic is arousing, parasympathetic is calming. Okay, then we have sensory neurons. Sensory neurons is going to carry incoming information from the senses outwards, then to the central nervous system. Motor neurons is going to carry information, outgoing information, so from the central to outwards. Then we have the interneurons, which is basically going to connect the two neurons. Okay, the fancy word for sensory is going to be afferent. So this is where sensation-wise, I'm going to hear the information come into my brain. Someone's going to say, oh, hi, Miss Yen, and I'm going to hear it with my hearing sense. So that's going to go inwards. Then the interneurons is going to be basically being like, oh my gosh, did someone say my name? Do I need to say something back? And so it's kind of in the process of the middle. And then my motor or efferent neurons is then going to exit and actually use motor movements and have my mouth say, oh, hi, so-and-so. And so the whole acronym for that is going to be SAME. So sensory is afferent, motor is efferent or afferent. So if you remember that, then you can remember the fancy names for the different neurons. So sensory is afferent, motor is for efferent. So SAME. Okay. Alrighty, so then again, the somatic nervous system is going to be your skeletal voluntary movements. So raising your hand, taking notes. Again, automatic is going to be more automatic. Autonomic is going to be more automatic, so things that we cannot control, like heart rate, digestion. Okay. Then again, review, sympathetic is going to be arousal, whereas parasympathetic is going to be the calming. Again, fight or flight, calming. Okay, spinal cord is in part of the nervous central system, and spinal cord will always be dealing with reflexes for the most part on the test. That and gait control theory, which is for pain, which we'll talk about. All right, and then we have your endocrine system. Endocrine system is going to be a way slower than the nervous system, and then communication is carried out by the hormones. Alrighty, so if nervous system is kind of fast like an email, endocrine system is going to be kind of more like snail mail, and it's going to take a while for it to work. All right, so hormones are chemicals synthesized by the endocrine glands and are secreted in the bloodstream. And this is, like all, you guys at your age, you're pretty hormonal right now. And so a lot of times when your hormones are, oopsie, sorry, my computer, I'll have to do a second section of this PowerPoint because my computer is running out of battery. Okay, it's going to be in your bloodstream, so it's going to affect your brain and many other tissues in your body. Alrighty, so then pituitary gland is called the master gland, and this is also controlled by which brain part as a review. Okay, the master gland is controlled by the hypothalamus. So that is the master of the master gland. Okay, and then we have thyroid and parathyroid glands. Again, I didn't really have a good trick for any of these. You just have to know that thyroid controls metabolism. And the way I remember that is the fact that some people that are maybe struggling with their weight have an underactive thyroid. So that way it's hard for them to lose weight. People that have a hard time gaining weight would have an overactive thyroid because then they have just a really fast metabolism and it's hard for them to gain weight. And then parathyroids basically helps the calcium in the blood. Okay, and adrenal glands, it's super important. Anytime you see adrenal glands, you want to think of adrenaline, which then is attached to which neurotransmitter. It is going to be epinephrine and norepinephrine because, again, norepinephrine is all of your A words. It's arousal, it's attention, it's adrenaline, which again is secreted by the adrenal glands. Okay, then we have gonads. They're basically your sex glands, are located in different places in the men and women. And so it's testes for men and then ovaries for women. Alrighty, that ends this portion. I'm going to plug in my computer so then we can continue on with the brain parts. Okay, if only I know how to stop this. What happened to it? I don't know. Where's the little thingy?